In example 8C, we are trying to compute the probability of being dealt a 4-card hand that contains no aces, okay? So how we're going to set this one up, okay, to get the probability of drawing such a hand, okay, remember you're going to have a fraction. The bottom is going to be all the possible outcomes. So the total number of, so I'll say number of total possible 4-card hands. That's what's going to go in the bottom. Okay, because we have to look at all the possible 4-card hands that could be dealt to us. In the numerator, we're going to try to compute the number of total possible 4-card hands that meet the criteria that we're looking for. We're trying to figure out the total number, so the number of total 4-card hands that contain no aces. All right, so let's do this. All right, so let's start with the denominator. Okay, I'll put that in red as I have been doing with the other examples. Okay, it's still going to be a combination. Anytime you're dealing with a hand of cards, that's a combination. Okay, we know that if we're trying to compute the total number of possible 4-card hands, there are no restrictions, so we're pulling from the entire deck. So out of all 52 cards, we're going to be choosing 4 of them. Okay. So that's going to give us the denominator of all the total possible number of 4-card hands. Okay, so if we actually go to our calculator, we can figure out what that is. All right, so let's go do that. Let's see here. So we're going to have 52 choose 5, or sorry, 4. 52 choose 4. That's going to give us 270,725 possible hands. All right. Okay, so that's the total number of possible 4-card hands. Okay, so now we've got to get into specifics. In the numerator, we want a subset of all the possible 4-card hands. We want 4-card hands that contain no aces. Okay, again, you're going to have a 4-card hand, so it's going to be a combination. So sorry, let me put that in green like I've been doing. All right, so for the numerator, it's going to be a combination. You're still going to have a 4-card hand, so you're going to be choosing 4. But remember, you want to ensure that you have no aces in your hand, okay? So you've got to go to the deck of cards, and let's talk about how we're going to select our cards. We're not going to pull from the entire deck because we could end up with an ace. Okay, so if we go over to our deck of cards, and let's go ahead and erase what we had previously circled, okay? We don't want an ace in our hand, okay? So what we're going to do is we're going to choose from all the remaining cards. We're going to exclude the aces, and we're going to choose from the remaining cards, okay? So remember, the full deck has 52 cards, okay? And then we're going to take out the 4 aces, and so we're going to be selecting from the 48 remaining cards, okay? So the numbered cards, and the jacks, the queens, and the kings, okay? So if we go back, let's write this down, okay? So our numerator, we're going to be choosing from the 48 cards that are not aces, okay? So let's go plug this into the calculator. We're going to do 48, choose 4, okay? So that's going to be your numerator, okay? So 194,580. All right. And so there is your probability. You do not have to reduce this, okay? If you did put this into a calculator to view the decimal, okay, let's do that. That should confirm that this is going to be a number between 0 and 1, which is what we want for probability. All right, so let's do this. And also, depending on how close that decimal is to 0, we can tell how likely being dealt such a hand is, okay? All right, so there we go, okay? There you go. That's actually pretty high. Okay, it's actually closer. It's all over 0.5, so it's closer to 1. Okay, so this is actually this could very likely happen. Okay, if you're playing cards. Okay, so we'll put about point. We'll round this to 0.7. I don't know. Let's see. Let's round it. Let's say 7187. Okay. All right, so not too bad. That's probably the most probable hand we've seen so far. All right, let's move on to the last one, okay? Hopefully you're getting the hang about how to do these, okay? It's just taking the counting one extra step to form the probability. All right, in part D, we're going to be dealing with a 7-card hand, and we want that 7-card hand to contain exactly 1 king and exactly 2 jacks, okay? All right, so again, the probability of this hand occurring, okay, is, let's see, the probability of this hand occurring is going to be, the denominator is going to be the total number of all possible 7-card hands with no restrictions. Okay. The numerator is going to be the total number of 7-card hands with 1 king and 2 jacks exactly. Okay. All right, let's start with the denominator. Definitely going to be easier here. Okay, I'll put that in red. All right, so we know that it's a hand of cards, so it's going to be a combination, okay? To figure out the total number of all possible 7-card hands, we're going to pull from the entire deck of cards. So we're going to be choosing from the 52 cards, and we're going to be dealt 7 of them, okay? So the denominator is going to be 52, choose 7, okay? Let's go to the calculator and go ahead and figure out what that is. So we're going to have 52, choose 7. All right, that is a large number. So let me go back and forth to write this down. So let's see here. And then we've got 7, 8, 4, 560. Okay, so here we go. There's your denominator. Lots and lots of possible 7-card hands there. Okay, make sure I got that written down right. Okay, good. All right, moving on to the top. Okay, the top, of course, is going to be a subset of all the total possible 7-card hands. We're looking for specific 7-card hands. We want 7-card hands that have exactly 1 king and exactly 2 jacks. Okay, so this was very similar to part B, where we had exactly 2 clubs. And so remember what we talked about in that example. You have to account for all the cards. Okay, so if you're being dealt a 7-card hand and you want it to have exactly 1 king and exactly 2 jacks, the 1 king and the 2 jacks, those are 3 of the 7 cards. You have to account for the 4 remaining cards as well, okay? All right, so for the numerator, remember what I told you, think of it as blanks. You've got 3 things going on. You need exactly 1 king, you're gonna have to handle that. You need 2 jacks, you're gonna have to handle that. And then you need the remaining 4 cards, okay? All right, so let's talk king first, okay? So it's going to be a combination, okay? You want to ensure that you get a king, okay? So you're not going to pull from the entire deck. The only way you can ensure that you're going to have a king is to pull from the kings, okay? And we know there are 4 kings in the deck, okay? So we are going to choose from the 4 kings, and we're going to select one of those cards, okay? So that's how you handle the king. Jack's going to be done in the same way, okay? It's going to be a combination because you have a hand of cards. There are 4 jacks in the entire deck, so you're going to be pulling from the jacks to ensure you end up with jacks, okay? And from those 4 cards, you're going to be selecting 2 of the 4 jacks, okay? And then now you've got to set up a combination to deal with the remaining 4 cards, okay? And again, it's 4 cards because it's a 7-card hand, and you've got 1 king and 2 jacks. That's 3 of the cards that have been accounted for, okay? All right, if you do not do this little piece, it's not going to come out correctly, okay? It'll actually compute in the numerator, it'll compute a 3-card hand for you, okay? You need to make sure it's a full 7-card hand, okay? All right, so for the remaining 4, okay, we know it's going to be a combination and we're going to be selecting the 4 remaining cards. The question is, how many cards are we choosing from to select the 4 remaining cards, okay? We know that the last 4 cards cannot be a king, and they cannot be jacks, okay? So if you go to your deck, okay, we're going to have to scratch out the jacks and we're going to have to scratch out the kings. But anything else will be fine in the hand, okay? So there's 52 cards in the deck. We're going to take away the jack, so subtract 4, and then we're going to take away the king, so we're going to subtract another 4. So we're subtracting a total of 8, so we're going to 44, okay? So we're going to be choosing from these remaining 44 cards, okay? All right, so let's go back over here. Let's put this number in. So to get the last remaining 4 cards in our hand, we're going to do 48 choose 4, okay? All right, so we've got a lot to go plug into the calculator here, okay? Let's see, we're going to do 4, oops, hold on. Let me get this calculator in your viewpoint. All right, so we're going to do 4 choose 1, okay? That's going to give us 4. Okay, so that's the first combination that we're looking at. Okay, and now we need to go do 4 choose 2. All right, so let's do 4 choose 2, and that's going to be 6. And then the last combination is 48 choose 4. So 48 choose 4, and that will give us 194,580. Okay, so to get your final number here, you're going to have to multiply the numbers in the numerator here. So let's see, our bottom is still going to be this number. Okay, let's go back to the calculator and multiply. So we're going to do this number that we just got. So that number times 4 times 6. Okay, so that's going to give us this number in the numerator. Okay. All right, so there we go. All right, so this is your probability. Okay, as you can see, your probabilities can get kind of crazy looking. That's okay. It's expected. Okay. When you start dealing with things like this, you know, you've got 7-card hands to deal with, for example, those numbers, the number of possible hands can get really high. So don't be alarmed from getting crazy looking numbers like this. Okay. Let's take a look at the decimal approximation here. So if we take this number and we divide by the denominator, let's see what we get. Okay, let me pull that denominator back up. There we go. Okay, so this is what we get. And you see, this is another, because this decimal is so close to 0, this is another rarity for a 7-card hand. Okay. All right, so I'll round this one. We'll say about 0.0349. Okay. Remember, the closer a probability is to 0, the less likely it is to occur. The closer the probability is to 1, the more likely it is to occur.